Hi, welcome to Lab 2, Magnetic Field of a Bar Magnet. So the purpose is to measure the distance-dependent magnetic field of a magnet and compare the observed versus predicted magnetic fields on and off axis. So the materials include a bar magnet, a magnetometer app, Excel spreadsheet, and 2 meter sticks. The results overview was that N was equal to negative 2.719 and the magnetic dipole moment was equal to 3.34. So here's the fundamental physics ideas. So first we have the Biot-Savart law, and this relates the magnetic field at a point to a tiny current element. And I put the formula below. And then second is the magnetic field of a dipole, which is a closed circulation of an electric current system. And then I put the formula there as well. And then last is the distance dependence formula, which is saying that the magnitude of the magnetic field due to a bar magnet falls off with distance. And there's that formula as well. First, I aligned the smartphone so that the magnetic field of the magnet bar was orthogonal to the Earth's magnetic field. Next, I found the magnetometer chip in the smartphone. It was in the upper left-hand corner. I then measured the distance from the phone to the bar magnet at specific magnetic field magnitude intervals. I then measured the off-axis magnetic field. This is shown in the image to the left. In this experiment, the system is the bar magnet and the surroundings are everything else. Which statements describe what was observed? When the magnetometer is far away from the magnet, it measures a near zero magnetic field in the x direction. As the magnetometer moves closer to the magnet, the measured x component of the magnetic field increases. Now to do my experiment calculations, first I measured the distance from the magnetometer to the magnet at each magnitude. The spreadsheet plotted the line of best fit and provided a formula for the line. I then used the slope and y-intercept to find the magnetic dipole moment using the distance dependence formula shown above. For the off-axis field, I found d perp and used that value to find the magnetic field off-axis. Now for the coding. First, I used my answer from the experiment and made the magnitude of the magnetic moment 3.34. I then created a function to find the magnetic field. This is in the first image. The second image shows how I created 2 vectors to represent the magnetic field on axis and 4 vectors to represent the magnetic field perp axis. The image above shows how I created the magnetic field off axis, and the image to the left shows the output of the code as well as the values of the magnetic field at each location. So there are some possible sources of error. First is the fact that other electronic devices could have been in the area. And the exact location of the magnetometer on my phone is unknown. Several assumptions were that the bar magnet acts as a magnetic pole and the magnetic field falls off as distance increases. A similarity between the two is that the charge that I calculated using the experimental data was relatively close to the values that my code predicted. Each model showed some differences because of the errors and assumptions listed above. Now for the discussion. So answering the what if questions. What if you hadn't oriented your setup so as to compensate for magnetic north? The magnetic field of the Earth would have conflicted with the magnetic field of the magnetic bar, which would skew the results. What if you redid the experiment, but instead of using a single magnet, you used the 2 identical magnets stuck together end to end? The magnitude of the magnetic field would double, but the direction would be the same. And that's it. Thanks for watching.